Welcome to Signal Ahead. I'm Alfred. Today's briefing, AI Developments Industry. Monday, August the 7th. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. There's a moment, if you read across the whole spread of what happened in the AI world over the past few days, where you notice something that doesn't announce itself. It's not in any single headline. It's the shape you see only when you lay the fragments side by side. And it's this. The frontier of artificial intelligence has quietly split into two frontiers that are moving in opposite directions, and almost nobody is talking about the gap widening between them. On one side, you have the machinery of deployment. Faster models, cheaper models. A price war breaking out between the big American labs as Chinese rivals close the distance. You have a new service tier promising 14 times the speed. You have a chief revenue officer being appointed. A chief revenue officer, mind you, which tells you everything about which phase of the industry cycle we've entered. The talk is of agents, of tokens per second, of cost efficiency, of shipping. This is the frontier of scale, and it is roaring. And on the other side, much quieter, far less garlanded, you have the frontier of understanding. The patient, unglamorous work of asking, do we actually know what these things are doing inside? And here I want to draw your attention to a piece of research that a casual reader would skim right past, because it concerns a model that generates text, not word by word, left to right, in the way we've grown used to, but by a diffusion process, many internal steps churning away before a single word appears on the page. The worry, put simply, was this. If a model does its thinking in a great mass of hidden vectors before it produces any legible token, then we lose the thread. We can no longer watch it reason. Its thought becomes opaque. And an opaque reasoner is, for anyone who cares about safety, a rather alarming object. Now here is the non-obvious part, the connection I'd invite you to hold on to for the rest of the hour. The researchers found that this particular diffusion model remained, against expectation, surprisingly legible. You could project its internal distribution down to a single most likely item and keep almost all of its performance. The apparent hidden depth was, for the most part, not hidden at all. It was interpretable, and even in the rare cases where those internal vectors were genuinely doing load-bearing computational work, what they encoded turned out to be something we already have a name for: superposition, packing multiple meanings into one channel. Readable, if you know how to read it. The tools we built for ordinary language models, the probes, the steering techniques, carried over. That's a good news story about transparency. But listen to the caveat attached to it, because the caveat is the whole point. This monitorability held, they said, because the diffusion model was derived from a text-pretrained language model, an efficient path, and therefore the one likely to be deployed. It might not hold for more general paradigms. In other words, we can see inside these systems partly by luck, partly because the cheapest way to build them happens, for now, to leave a window open. And do you feel the tension between my two frontiers now? Because the frontier of scale, the one with the price wars and the revenue officers and the 14 times faster tier, that frontier does not optimize for the window staying open. It optimizes for cost, for speed, for capability. If one day the most efficient architecture is one that thinks entirely in the dark, the market will build it, and it will build it before the understanding people have finished their paper. You can see the same crack running through the smaller stories, if you know to look. Someone describes a code base grown so convoluted that no engineer on the team can say where the data comes from, so they ask the model, and they sit watching a confident wall of text neither of them can verify. That is, in miniature, the entire predicament. Capability racing, ahead of comprehension. A machine we lean on precisely at the moment we've stopped being able to check it. And it rhymes, oddly, with the delightful little trick of telling a model to hallucinate a category and then snapping that invention back to reality with embeddings. useful, clever, and built entirely on the assumption that we can always find the tether back to something true. So here is the argument I want to lay before you over the next while. The state of the field is not, as the headlines suggest, a simple story of acceleration. It's a story of two accelerations pulling apart: deployment sprinting, understanding jogging behind, and of the narrowing set of lucky circumstances that still let the second keep the first in view. Whether that window stays open is, I'd wager, the most important question in the industry that no one is pricing. Let's find out why. Let me tell you what I think is actually happening underneath all of this, because if you squint at the flurry of the past few weeks, the model releases, the price cuts, the little tools built in an afternoon, the diffusion-based architectures being poked and prodded, you might mistake it for a chaos of unrelated events. It isn't. There's a current running beneath it, and the current has a direction. Consider first the sheer texture of the news. A new Gemini Flash arrives, and within hours, someone has updated a plugin so they can talk to it, ask it to draw a pelican riding a bicycle, and note with some amusement that the resulting image renders correctly in one browser and vanishes entirely in another. Meanwhile, a Chinese lab releases its latest model with no announcement page at all. The benchmarks apparently posted to a private messaging group, copied to a forum, deleted for being low effort, then reconstructed as ASCII art on another forum. And at the same time, the two best-funded Western labs are quietly cutting prices, releasing cheaper models, because rivals are gaining ground. Put those three things side by side, and you can feel the temperature of the water. Capability is no longer scarce. It is becoming a commodity, and it is commoditizing fast. That is the deep current. The value in this industry is migrating away from the model and toward everything that surrounds the model. When a frontier-class system is expensive, rare, and hard to run, owning it is the whole game. But when you can run a capable model on a laptop and on a small desktop machine at your kitchen table, when there are 3 or 4 labs racing each other to the bottom on price, then the model itself stops being the prize. The prize becomes what you build around it, how you wire it into the world, and, crucially, whether you can understand what it's doing when it does something you didn't expect. Watch how people are actually working now. Someone has an idea in the shower, hands it to a coding agent, and by lunchtime there's a working library that speaks to multiple databases. Someone else, faced with a blog carrying nearly 2,000 tags, doesn't laboriously feed the vocabulary to the machine and ask it to classify. Instead, they invert the whole thing, let the model hallucinate the tags it imagines might fit, then use embeddings to snap those inventions onto the real vocabulary nearest to them. That is a genuinely clever move, and it tells you something. The skill is no longer in commanding the model. The skill is in designing the scaffolding around its confident guesses so that the guesses become useful rather than dangerous. And there precisely is where the current turns treacherous, because the same forces that make capability cheap also make comprehension optional. There's a scene I keep returning to: an engineer and a colleague sitting shoulder to shoulder, staring at an endless wall of text streaming across the screen, watching an AI attempt to fix a bug for the 4th time, a bug in a feature nobody on the team can any longer explain. Where does the data come from? I don't know. Let me ask Claude. Neither of them can tell whether a single line of what the machine produces is true. It merely seems very confident. The project has grown so many layers, so many services, that understanding has quietly evaporated from the organization that owns it. This is the shadow side of the same trend. As models become cheaper and more fluent, we outsource not just the labor, but the knowing. And that is why I find the quieter, more technical work so important. The people painstakingly asking whether these newer architectures can even be watched. Take the diffusion-based text models, where generation happens not left to right, but through many refining passes, carrying not just tokens, but hidden vectors between steps. That's a lot of serial computation happening in the dark, and the worry is obvious. If we can't read those intermediate states, the model has depth we cannot monitor. The encouraging finding is that, at least for models grown out of ordinary text-trained systems, you can project down to the single most likely item at each step and lose almost nothing. The reasoning stays legible, the interpretability tools carry over. The confidence in that vector, it turns out, is largely legible after all. Hold those two scenes together. In one, comprehension is quietly abandoned because the machine is fluent and the deadline is near. In the other, researchers fight to keep comprehension possible even as the architecture grows stranger. The deep current is not merely that AI is getting cheaper, it is that we are being offered, everywhere, a standing temptation to trade understanding for output, and that the only durable moat left, once capability is free, is the discipline of knowing what your systems are doing. The labs cutting prices understand the first half. Whether anyone is pricing in the second half is the question that ought to keep us up at night. Let us end where the week actually left us, not with a single thunderclap of an announcement, but with a scattering of small signals that, taken together, tell you rather more than any one of them intends to. Consider what crossed the wire. A diffusion-based language model, examined closely, turns out to keep its reasoning legible, even though it performs a great deal of hidden computation before it commits to a word. 2 American laboratories, having enjoyed something like a comfortable dominance, quietly cut their prices in response to Chinese rivals who keep releasing capable models, sometimes announced not on a press page at all, but in a group chat, copied to a forum, deleted for being low effort, and finally preserved as an ASCII table on a hacker's notice board. A developer builds a small tool in an afternoon, then builds a whole library in the time it takes to shower by delegating the research spike to a model and reviewing the commits. And somewhere in the background, a team stares at an endless wall of confident text, neither person quite able to say whether any of it is true, having lost track of where their own data even comes from. What do these have in common? I want to suggest they are all reports from the same frontier, the frontier of legibility. The question underneath the whole enterprise is no longer, can the machine do it? That question, for a startlingly wide range of tasks, has quietly been answered, yes. The question that now organizes everything is, can we still understand what it did and why and whether to trust it? Notice how much hangs on that. When researchers get excited that a diffusion model remains monitorable, that you can project its internal distribution down to a single most likely item and lose almost nothing, that its interpretability tools carry over from the older architectures, the excitement is not about capability at all. It is relief that a new and more efficient way of building these systems did not cost us our ability to look inside them. That is a second-order concern, and it is precisely the kind of concern that gets trampled in a price war, because here is the first thing to watch. The economics and the legibility are pulling in opposite directions. Cheaper, faster, more competitive, the 14 times faster inference tier, the trillion-dollar ambitions under sudden pressure, all of that rewards whoever ships the most capable model at the lowest cost. None of it rewards whoever ships the most understandable one. The market prices performance. It does not yet price transparency. And so, the good news about the diffusion model is fragile good news. Because it depended on that particular architecture being derived from a text-pretrained ancestor we already knew how to inspect. The researchers were candid. This reassurance may not survive a more exotic paradigm. When the incentive is speed, and the safeguard is an accident of lineage, you should not expect the safeguard to hold. That is the macro picture. But watch the micro picture too, because it rhymes. The developer who conjures a working library before breakfast is living the upside of all this. Genuine leverage, genuine delight. The SVG rendering as the tokens still stream in. But turn the page and you find the same power producing the team who no longer know where their data comes from, asking the model to fix a bug. The model wrote, in a system grown so layered that no human holds the whole of it in their head. The phrase that lodged in me was that this is removing the middle class of software engineering, hollowing out the tier of people who used to understand a system well enough to reason about it, leaving a thin layer of prompters above and an opaque machine below. That is legibility again, at the scale of a single codebase. The individual engineer is facing, in miniature, exactly what the alignment researcher faces at the scale of a model: computation you did not perform, cannot fully trace, and must nonetheless decide whether to trust. And there is a lovely, slightly mischievous instance of the whole tension in the trick of not classifying but hallucinating, letting the model invent a plausible tag freely, then quietly snapping that invention back to a known vocabulary with embeddings. That is the shape of the wise posture, I think. You let the machine do the fluent, ungovernable thing it is good at, and then you build a scaffold of the interpretable and the known to catch it before it touches anything that matters. The hallucination is powerful. The mapping back to reality is what makes it safe. So what to watch as the weeks turn? Watch whether transparency ever acquires a price. Whether a market that currently rewards only capability learns to reward legibility before it needs to. Watch the supply chain, because a single compromised package leaked terabytes, and the government now authorizing private firms to hack back, tells you the trust perimeter is dissolving. And watch, in your own work, the small moment where you stop asking how it did that. That is the moment to slow down. The frontier was never really about what these systems can do. It is about what we can still understand, and whether we choose to keep understanding it. That's the signal for today. The noise will keep coming. We'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.